Greetings, this is Mr. Caslin. Today I want to talk about a little more methodical way of solving a system of equations using matrices. This is a system of equations with 3 variables and 3 equations. We're looking for the simultaneous solution that will solve all 3 of these equations at the same time. And you can do these using matrices. Now, we've talked actually about 2 different ways of doing this. One is, and I could be wrong about this, but I think they call this Gauss-Jordan Elimination, where all you're looking for is this pattern here. You're going to make a matrix, and you're trying to make this a 0, this a 0, this position a 0, and this position a 1. Basically, whatever number you end up with here, that's going to be your z. So you get z is equal to some number, say 4, and then you're going to create an equation on what's left here. Something like, 3y plus 7x is equal to negative 14, and plug in your z and find out what y is. And now that you have your y and your z, plug that into this equation that you create out of this and solve for x. Now, I'm finding more and more people think that's confusing, so I think a better approach is we're going to work the matrix all the way through and just get your identity matrix on the left. Okay, we've done this a bunch. Let's get just get the identity matrix on the left, and these numbers will fall through. Now, the best way to do this, and the way that will allow you to do this quickest, is work from left to right. Find this 1 first, and then this 0 and this 0. Okay, so complete this column first, then move over and complete this column to get this pattern, and then get this pattern in this column. Okay, if you move from left to right, as you make changes, it won't mess up what you've already done on the left. Okay, so let's go through an example with that and see if this works out rather quickly. Instead of just randomly trying to fill in these 1s and 0s and make them work, if you move from left to right, it will be a little more accurate for you. Okay, so this is the matrix created out of that equation, the original equation that we had up here. Okay, so I said in this first column on the left, let's make this a 1. So what can we do to make that a 1? Well, what we have is our new row 1 is going to be equal to our old row 1 times negative 1. So we're just reversing all the signs on here. Okay, so our new row 1 would be 1, negative 1, negative 2, negative 1, and then all the other 2 rows remain the same. Okay, now stay in this column. Do this, row 2, column 1, make that a 0 next. Okay, so how can we do that? Well, we can say that new row 2 is equal to old row 2 minus 2 times row 1. Okay, so we get 2 minus 2 here, we'll create a 0. Alright, now let's see what would happen. Alright, that would give us a 0, then we'd have 3 minus negative 2, which is the same as 3 plus 2, so we'd have a 5. We'd end up with a 5. And we'd end up with a 0. Okay, keep going down this first column. Make this one a 0. We'll do kind of a similar approach. We'll say new row 3 is equal to old row 3 minus 5 times row 1. Now it's nice to have some sort of record of what you've been doing. If you need to go back and figure out what you did, or your teacher or someone else needs to see what you did, use this nomenclature here to help you document the steps that you did. Okay, so we got a new row 3. Row 3 minus 5 times row 1, which here would give you 5 minus 5. Give us a 0. Here we'd have 4 minus 5 times negative 1, which would give us a 9. If you keep going, you're going to find out that this is 12. And this is 9. Okay, so we completed our first column. Here's my highlighter. So we've got this in place, and the fact that these are now ones and zeros is going to help us when we work on these other columns. These zeros are going to help us by not changing. When we use multipliers, you're multiplying by 0, and that's big. That's going to be a big help. Okay, so you won't undo what you've already done. Okay, so what I recommended next was in this second column, find the 1 first. You're trying to make this 501. It looks like we could just take row 2, multiply it by 1/5. Okay, I think that's going to be helpful to us. 1/5 times 0 is still 0. 5 times 1/5, you get a 1, 1, 0. Other two rows remain the same. Right, much easier if you only change one row at a time. Okay, we need a 0 here. It looks like we get a 0 in new row 1 by taking old row 1 and adding row 2. Okay, here's why, if we work from left to right, so you're not messing up this column, you get a 1 plus 0. It stays 1, and everything in the world is good. Okay, so we're adding these together. You're going to get a 1 here. You get a 0 here. Negative 2 plus 1 is negative 1. And you get a negative 1 here. All right, keep going down the second column. We need a 0 here now. Okay, so we need a new row 3. So let's do row 3 is equal to old row 3. Oh, excuse me. Minus 9 times row 2. Okay, that's why you want to get that 1 first in the column, and you can use that 1 to work with your multipliers. Okay, so 0 minus 9 times 0, your 0 remains here. Get 9 minus 9 here. You created a new 0 here. You get 12 minus 9, which is 3. And 9 minus 0, which is 9. Okay, so we're working left to right. Notice we're not messing up the columns that we've already established. So now we've got column 1, column 2. Highlight that for effect. We've established our column 1, our column 2. Now we work with column 3, and these zeros that are in place will help those columns not get messed up. Okay, so what do we need? We need a 1 down here. Looks to me like we could say the new row 3 is equal to old row 3, and we can just multiply by 1/3. Okay, these zeros here will stay the way they are. We'll get a 0, 0, 1, and 3. Looks like we're getting closer and closer to where we need to be. We need a 0 here. It looks like we could add row 3 and row 1 together. Okay, so our new row 3 is equal to old row 3 plus row 1 oh, I'm sorry. Looks like when I set this up, sorry, it's the top one. We have our 1 here. We want to work downward. So let's make this a 0 here first. Okay, so let's change our row 1. I'm just going to say 1 plus 3. Row 1 plus row 3. So we'll get a 1 plus 0 is 1. 0 plus 0. And negative 1 plus 1 is 0. And here we're going to have a negative 1 plus 3, which is 2. Okay, first column, second column, we're working on a third column. We need this to be 0 here. I think we can achieve that by saying our new row 2 is equal to old row 2. Let's just take 1 minus 1, so we'll subtract row 3. We end up with 0, 1, 0, and then 0 minus 3, which would be negative 3. Again, see how the zeros that we've established on the left help those columns the columns on the left not change. All right, we have our identity matrix. That means we've solved our problem. You've got x is equal to 2, y is equal to negative 3, and z is equal to 3. All right, this methodical way is much better. There's not a lot of guessing on what you should do next. Establish your first column. Get your 1 first, then your zeros. Go to your second column, get the 1 and then the zeros. Go to third column, get the 1 and zeros. And I think that you'll find this works every time. All right, for those of you that have some snow days, enjoy it. And then we'll see you next week.